Now, in this lecture, we'll find out the area of the semicircle using 4 different methods. In the drawing, we have a semicircle that is inscribed by triangle ABC. Triangle ABC is a right triangle, angle ABC equals to 90 degrees. We also know that BC equals to 5 units. So here BC equals to 5 units and AB equals to 12 units. And we want to find out the area of this semicircle. So first of all, we will define the center of this semicircle as point O, and we will also define the point of tangency of tangent AC in this semicircle as point D. Then we will join together points D and O by a straight line. Actually, line segment DO, this line segment DO is the radius of this circle, so we define it as R. It is the radius of this semicircle because of the fact that line segment DO starts from the center of this semicircle, that is to say it starts from point O and ends at point D. That is a point on the semicircle itself, therefore it is the radius of this semicircle, so we defined it as R. Likewise, OB is also the radius of this semicircle for the same reason. And we actually know that AB, side AB of triangle ABC equals to 12 units and BO equals to R. So actually AB minus BO equals to AO. That is to say AO equals to AB, that is 12 units, minus OB, that is R. Or AO equals to 12 minus R. AO equals to 12 minus R. Okay, and we also have a rule, we call it rule number 1. According to rule number 1, if we have a circle and we know that the center of this circle is at this point, we define it as point O, and we have also tangent AB to this circle. So actually this tangent AB of this circle, tangent AB is tangent to this circle at this point. We'll define the touching point between the tangent AB and the circle as point M. Actually, point M is the point of tangency. Point M is the point of tangency of tangent AB with this circle. We will join points O and M together by a straight line. OM is the radius of this circle, so we define it as R. And as you can see here, the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. So actually, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So you can write down rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So actually here you can see that the tangent AB is tangent to this circle at point M, and we have the radius OM, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so we actually can implement rule number 1 in our drawing, because in our drawing we have tangent AC or tangent CA is perpendicular to this tangent CA is tangent to this semicircle at point D, and so point D is the point of tendency of tangent CA with this semicircle, and we have this radius, the radius OD, it is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tangency, tangent AC with this semicircle. Therefore, according to rule number 1, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Why? Because the tangent OD is drawn to the point of tendency. Therefore, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And If we focus on the right triangle, triangle ABC, on the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of this big right triangle, triangle ABC, is AC, so the square of the hypotenuse is AC square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CB square plus AB square. So I'll repeat again. According to the Pythagoras theorem, on the right triangle, triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is AC square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CB square plus AB square. So actually, AC square equals to CB square. CB equals to 5 units. So CB square is 5 square. 5 square is 25 plus AB square. AB equals to 12 units, so AB square is 144. So in conclusion, we found out that AC square equals to 24 plus 144, 25. AC square equals to 25 plus 144, 25 plus 144, it equals to 169. So AC square equals to 169. AC square equals to 169. We take a root of this equation number 1, and we'll get that AC equals to the square root of 169, that is actually 13. AC equals to 13. So we can write here that AC, the hypotenuse of triangle ABC, equals to 13 units. In the next step, we'll focus on the big right triangle, triangle ABC, and on the small right triangle, triangle ADO. Okay? On the small right triangle, the small right green triangle, triangle ADO. And we will actually prove that those two right triangles are similar to each other. Okay? So we'll actually prove that the right big triangle, triangle ABC, is similar to the right small green triangle, triangle ADC. Why they are similar to each other? Because first of all, we know that those two angles, they are both right angles. That is to say, they are equal to 90 degrees, therefore they are equal to each other. So this angle, that is angle ABC, triangle ABC, is equal to this angle, that is actually angle ADO, of triangle ADO. And both angles are right angles, that is to say they are equal to 90 degrees. So here, angle ABC equals to angle ADO, and they are both equal to 90 degrees. And we also have this angle is a common angle that belongs to both triangles. This angle belongs to triangle ADO, and this angle also belongs to the big right triangle, triangle ABC. So we can write down that angle CAB equals to angle DAO. So it is a common angle that belongs to both triangles. So we're actually saying that the angle equals to itself. Why? Because it belongs to both triangles. So angle CAB of triangle ABC equals to angle DAO of triangle ADO, because of the fact that it is a common angle that belongs to both triangles. So we can write down that this angle equals to itself. Okay? And we also have those two angles are also equal to each other according to third angle theorem. So this angle, that is actually angle ACB, is equal to this angle, that is angle DOA, and they are equal to each other according to third angle theorem. I will repeat again. Angle ACB equals to angle DOA, and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And in those two triangles, triangle ABC and the green triangle, we found that those two angles of triangle ABC congruent to those two angles of the green triangle, triangle ADO. So we have two pairs of angles that congruent in those two triangles. Therefore, these angles that are defined as the third pair of angles must also congruent. That is to say, these two angles are equal to each other, according to third angle theorem. Okay, so we actually found out that all the angles inside the big right triangle, triangle ABC, congruent to all three angles of the green right triangle. Therefore, we can write down that triangle ABC, the big right triangle, triangle ABC, is similar. This is the sign of similar. It's similar to triangle ADO. According to angle similarity rule. I repeat again. We actually proved that triangle ABC is similar to triangle ADO according to angle similarity rule. So what is angle similarity rule? Angle similarity rule states that if all angles in one triangle can go into all the angles in another triangle, then the two triangles can go into each other according to angle similarity rule. Okay, and from the fact that triangle ABC is similar to triangle ADO, we will conclude that BC over AC triangle ABC is equal to OD over AO in triangle ADO. Okay, I'll repeat again. We will conclude from the fact that triangle ABC is similar to triangle ADO that BC over AC equals to DO over AO. And we know that BC equals to 5 units. It is given us in the question. AC, we have already found out that AC equals to 13 units. And OD is the radius of the semicircle, that is to say it equals to R. And OA, we have already found out that OA or AO equals to 12 minus R. So in conclusion, we found out that 5 over 13 equals to R over 12 minus R. Here we will cross multiply equation number 2 and we will get that 5 times 12 minus R equals to 13R. Here we will open the brackets in this side of equation number 2 and we will get that 5 times 12 is 60, 5 times minus R is minus 5R, and it equals to 13R. Here we will add 5R to this equation number 2, and we'll get that 5R plus 13R is 18R, equals to 60. We will divide this equation by 18 and we will get that the radius of the semicircle equals to 60 over 18. Here we will divide both the numerator and the denominator of this number by 6. 60 over 6 is 10 and 18 over 6 is 3. So actually, in conclusion, we found out that the radius of the semicircle equals to 10 over 3. That is to say, R equals to 10 over 3 units. And we know that the area of the semicircle so actually that is the sign for the area. The two brackets are the sign for the area. It means the area of the semicircle equals to pi r square over 2. Okay, and we have already found out that r equals to 10 over 3, so it will be equal to pi r square is 10 over 3 square, all divided by 2. So the area of the semicircle equals to pi, and 10 over 3 is 100 over 9, all divided by 2. So it is pi times 100 over 2 is 50 over 9. Or the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So I repeat again, we actually found out that the area of the semicircle, the area of this semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this semicircle according to a second method. According to a second method, we will actually, I will present to you a new rule, rule number 2, but I will not repeat on the same things that we did on rule on the first method. So in the first method we have already found out, so this is the center of the circle is point O, AB equals to 12 units, OB equals to R, AO equals to 12 minus R. The touching point between AC and the semicircle is point D. OD is the radius of the semicircle. That is to say, it equals to R. We have already found out that those two angles, they are both right angles. This angle is a right angle, and this angle is also a right angle. And we know that BC equals to 5 units, and AC equals to 13 units. And now I'll present to you rule number 2. According to rule number 2, I write it down and then I will explain the rule. According to rule number 2, actually you can call it rule number 2 or 2 tangents theorem. Two tangents theorem. So actually, two tangents theorem or rule number 2 states that the lengths of two tangents from a common external point to a circle are equal. So I write rule number 2 again. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and we also have this point is point P. Point P is a common external point. It is external point because of the fact that point P is not located inside this circle nor on this circle, but it is located outside of this circle. For that reason, it is defined as external point of this circle. So if the external point P will draw two tangents to this circle, so the first tangent, this will be the first tangent, and we will define the point of tangency of the first tangent with this circle as point A. This is the touching point between the tangent and the circle, and we will draw also from point P a second tangent to this circle. So this is the second tangent, and we define the touching point between the second tangent and the circle as point B. Point B is the point of tangency of the second tangent with this circle. So the length of the first tangent is PA, and the length of the second tangent is PB, and according to rule number 2, two tangents theorem, the lengths of two tangents, that is to say PA and PB, from a common external point, that is to say from point P to a circle, are equal. That is to say the length of the first tangent is PA. The length of the second tangent is PB, and according to two tangent theorem, the lengths of those two tangents are equal to each other. That is to say, PA is equal to PB. Okay, PA equals to PB. According to rule number 2 of two tangent theorem, PA equals to PB. So whenever you draw from a common external point two tangents to a circle, like in this drawing, then the length of those two tangents will be equal to each other. In this case, PA will be equal to PB. Okay, that is the two tangent theorem, and we can implement two tangent theorem in our drawing, because in our drawing we have the external point, point C. Okay, here, this point, point C, is an external point of this semicircle, and from the external point, point C, We have actually two tangents to this semicircle. The first tangent is tangent CB, and the second tangent is tangent CD. And according to rule number 2 or two tangents theorem, whenever you draw two tangents to a circle from a common external point, like in this drawing, from the common external point C, we have two tangents to this circle, tangent CA, CB and tangent CD, then the length of those two tangents will be equal to each other. That is to say, CB will be equal to CD. Okay, so according to two tangents theorem, CB equals to CD, CB equals to CD, okay, this is according to rule number 2 or two tangents theorem, CB equals to CD. But it is given us in the question that CB equals to 5 units. CB or BC, it is the same, equals to 5 units. So we can write down that here that CB equals to 5 units. And from this equation, we will conclude that CD also equals to 5 units. Okay, CD also equals to 5 units. So we can write here that CD equals to 5 units. So we actually found out that the line segment CD equals to 5 units. And we know that AC, that is the hypotenuse of triangle ABC, is equal to 13 units. AC minus DC equals to AO, okay? Again, AC minus DC equals to AD. Again, AC minus DC equals to AD. Okay, I will write here that AC minus DC equals to AD. Here, AC minus DC equals to AD. We have already found out that AC equals to 13 units. And we also found out that DC equals to 5 units. That is to say, AD equals to 13 minus 5. 13 minus 5 is equal to 8 units. So we found out that AD equals to 8 units. So we can write here that AD equals to 8 units. Now we actually can implement the Pythagoras theorem in the right green triangle ADO. Okay. So in the right green triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse is the angle, is the side that is in front of the right angle. That is to say, the hypotenuse is AO, so the square of the hypotenuse is AO square. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to AD square plus DO square. I'll repeat again. In the green right triangle, triangle ADO, according to the Pythagoras theorem, AO square equals to AD square plus DO square. AO equals to 12 minus R, so AO square is 12 minus R square, and it equals to AD square. AD equals to 8 units, so AD square will be equal to 8 square is 64 plus DO square. DO equals to R, so DO square will be equal to R square. So in conclusion, we found out that according to equation number 1, 12 minus R square equals to 64 plus R square. We will open the brackets on this side of equation number 1, and we will get that 12 minus R square is equal to 144 plus R square minus 24R, that equals to 64 plus R square. Here we have R square on both sides of equation number 1, so R square will get cancelled, and what is left from equation number 1 after we cancelled R square, what is left here, we have 144 plus 144 minus 24R equals to 64. We will subtract 64 from this equation, equation number 1, and we will get that 144 minus 64 is 80. So here we will have 80 minus 24R equals to 64 minus 64 is 0. We will add 24R to this equation, equation number 1, and we will get that 24R equals to 80. Here we will divide equation number 1 by 24, and we will get that the radius of the semicircle equals to 80 over 24. We will divide both the numerator and the denominator of this number by 8, and we will get that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units. Okay, and we'll continue according to the first method. The area of this semicircle, it is actually equals to pi r square over 2. So it equals to pi, r is 10 over 3, so r square is 10 over 3 square over 2. So it equals to pi, 10 over 3 square is 100 over 9, all divided by 2. So here 100 over 2 is 50. In conclusion, we get that it equals to 50 pi over 9 square units, or in terms of numbers, the area of the semicircle will be equal to 17.45 square units. Okay? We finished with the second method. In the next step, I will present to you how to find out the area of this semicircle according to a third method. In the third method, in the third method, we will do a construction. We will actually draw a mirror image. Here we have this image. So here we will draw a mirror image of this figure, and then we will join the two figures together. Okay, here is actually like this. Okay, so we will draw a mirror image of this figure, and then we will join the two figures together. Okay, so here we'll draw here the mirror image of this figure, and we'll join them together. Okay. So I actually draw a mirror image of this figure and then join them together and we get this figure. We define the vertex here as point D. So we got here a circle that is described by triangle ADC, and actually, as you can see, AB is perpendicular to DC, so AB is the height to the base BC because it is actually an isosceles triangle. AC equals to 13 units and it will be equal to AD that is also equals to 13 units. BC equals to 5 units and it equals to DB that is also 5 units. So DC will be equal to 5 plus 5, that is to say it will be equal to 10 units. And the area of this triangle ADC, the area of triangle ADC equals to the base of the triangle, that is actually the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of triangle ADC, this triangle that is an isosceles triangle, the area of triangle ADC will be equal to the base of the triangle. The base of the triangle is BC times the height to the base. The height to the base is AB because the height must create 90 degrees with the base, and AB indeed creates 90 degrees with the base. So it is actually AB over 2. So the area of triangle ADC is equal to BC. BC equals to, no, the area is the base. The base is DC. The base is DC. Okay, as you can see, the base is DC. And DC equals to 10 units. The height AB is equal to 12 units over 2. So the area of this triangle ADC, it equals to 120 over 2 is 60 square units. 60 square units. That is the area of this triangle ADC. Okay. So here we have this circle is inscribed by triangle ADC, and therefore the radius of this circle, whenever you have a circle that is inscribed by a triangle, then the radius of this circle will be equal to the area of the triangle that blocks the circle over the semi-perimeter of the triangle. I will repeat again. The radius of the circle that is inscribed by a triangle is equal to the area of the triangle that blocks the circle. In this case is ADC, the area of triangle ADC over the semi-perimeter of triangle ABC. The semi-perimeter of triangle ADC. And the semi-perimeter of any triangle is equal to the perimeter of the triangle over 2. And we already found out that the area of triangle ADC equals to 60 square units, and the semi-perimeter will be equal to AD plus AC, AD plus AC plus DC over 2. AD plus AC is 13 plus 13 plus DC is 10 over 2. So 13 plus 13 is 26. 26 plus 2 is 36. 36 over 2 is 18. So we found out that the semi-perimeter of triangle AEDC equals to 18 units, and 60 over 18, we will divide both the numerator and the denominator by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle, the radius of the circle that is also the radius of the semicircle, is equal to 10 over 3 units, and the area of the semicircle, is equal to pi r square over 2. And we found out that r equals to 10 over 3, so r square will be equal to 10 over 3 square over 2. So it equals to pi, 10 over 3 square is 100 over 9, all divided by 2. 100 over 2 is 50, so in conclusion we found out that the area of the semicircle equals to 50 pi over 9 square units, so in terms of numbers, it equals to 17.45 square units, according to the third method, okay? And in the next step, I will present to you how to find out the area of this semicircle according to the fourth method. In the fourth method, here we know that AC equals to 13 units. This is point O, this is point D. OD is the radius of the semicircle. OB is also the radius of the semicircle. AO is equal to 12 minus R. And this angle equals to 90 degrees, and this angle, it is also a right angle. And here BC equals to 5 units. And if we focus on the right triangle, triangle ABC, we will define angle BAC as theta. And if we focus on the right triangle, triangle ABC, then in the right triangle, triangle ABC, sinus theta equals to CB over AC. I will repeat again. On the right triangle, triangle ABC, sinus theta equals to CB over AC. But we know that CB equals to 5 units and AC equals to 13 units. I'll repeat again. CB equals to 5 units and AC equals to 13 units. So in conclusion, we found out that according to equation number 1, sinus theta equals to 5 over 13. In the next step we will focus on triangle ADO, the right triangle. The right green triangle, triangle ADO. So here sinus theta equals to DO over AO. I'll repeat again. On the right triangle, triangle ADO, sinus theta equals to DO over AO. But we know that DO equals to R, it is the radius of the semicircle, and we have already found out that AO equals to 12 minus R. So in conclusion, we found out that sinus theta, according to equation number 2, equals to R over 12 minus R. I will repeat again. According to equation number 2, sinus theta equals to R over 12 minus R. And according to equation number 1, sinus theta equals to 5 over 13. So we create equation number 3 that states that sinus theta according to equation number 1 equal to sinus theta according to equation number 1 equals to sinus theta according to equation number 2. So sinus theta according to equation number 1 is 5 over 13, and it must be equal to sinus theta according to equation number 2, that is actually R over 12 minus R. So we got equation number 3 that states that 5 over 12 equals to R over 12 minus R. Here we will multiply equation number 3, and we will get that 5 times 12 minus R equals to 13R. We'll open the brackets on this equation number 3, and we'll get that 5 times 12 is 60. 5 times minus R is minus 5R, and it equals to 13R. We will add 5R to this equation number 3, and we will get that 13R plus 5R is 18R. It equals to 60. We will divide this equation number 3 by 18, and we will get that the radius of the semicircle equals to 60 over 18. Here we will divide both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 16 over 6 is 3. So in conclusion, we found out that the radius of the semicircle is equal to 10 over 3 units, and the area of the semicircle is equal to pi r square over 2. That is to say, it equals to pi, r is 10 over 3, r square is 10 over 3 square over 2, so it equals to pi r square is 10 over 3 square. 10 over 3 square is 100 over 9, all divided by 2. 100 over 2 is 50, so it's 50 pi over 9. So in conclusion, we found out that the area of the semicircle, according to the fourth method, it equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, so we finished with the fourth method. In the next step I will summarize the lecture. Actually, we wanted to find out the area of the semicircle, this semicircle, and we know that BC equals to 5 units, AB equals to 12 units, and ABC is a right triangle. This angle equals to 90 degrees. And we want to find out the area of this semicircle that is actually inscribed by triangle ABC. Okay, so first of all, I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and the center of this circle is point O, OM is the radius of this circle, and we have tangent AB that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle, and we have this radius that is drawn to the point of tendency. Therefore the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so whenever you have a radius that is drawn to the point of tendency, like in this drawing, then the tangent will be perpendicular to the radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Actually, we can implement rule number 1 in our drawing, because in our drawing we have this radius, the radius OD. It is drawn to the point of tendency. That is to say, it is drawn to point D, that is the point of tendency of tangent AC with this semicircle. Therefore, the tangent CA will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, and we know that actually OD is the radius, OA, OB is also the radius, and OA equals to AB minus OB. That is to say, it equals to AB that is 12 units minus OB that is R. So OA equals to 12 minus R. Okay, and here we'll find out the value of the hypotenuse AC according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In triangle ABC, the square of the hypotenuse is AC square, and it equals to the sum of the square for the perpendiculars. That is to say, it equals to CB square plus AB square. So AC square equals to CB square. CB equals to 5, so CB square will be equal to 5 square. 5 square is 25, plus AB square. AB equals to 12, so AB square will be equal to 144, and 25 plus 144 is 169. So we found out that AC equals to AC square equals to 169. We took a root out of this equation number 1, and we found out that AC equals to the square root of 169. The square root of 169 is 13, so we found out that AC equals to 13 units, the hypotenuse equals to 13 units in its name. Then we actually proved the triangle ABC is similar to triangle ADO. Why they're similar to each other? Because we have those two angles, they are both right angles. So we proved that the right triangle is similar to the big triangle, triangle ABC. We have those two angles that are both right angles, therefore they are equal to each other. This is to say angle ABC equals to angle ADO equals to 90 degrees. This angle is a common angle, it belongs to both triangles. So this angle equals to itself. We can also write down that angle CAB equals to angle DAO, that is a common angle. And those two angles are also equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. We have those two angles in triangle ABC are congruent to those two angles in triangle ADO, the green triangle. So we have two pairs of angles that are congruent, therefore the third pair of angles, those are the third pair of angles, must also congruent. Okay? So we actually proved that all three angles of triangle ABC congruent to all three angles of the green triangle, therefore we proved that triangle ABC is congruent to triangle ADO according to angle similarity rule. From the fact that those two triangles congruent to each other, we will conclude that BC over AC in triangle ABC equals to DO over AD in triangle ADO. BC over CA in triangle ABC equals to DO over AO in the green triangle. BC over AC in triangle ABC equals to DO over AO in triangle ADO. BC equals to 5 units, AC equals to 13, DO or OD equals to R, the radius of the semicircle, and AO equals to 12 minus R. Because multiplied this equation number 2, and we got that 5 times 12 minus R equals to 13R. We opened the brackets on this side of the equation number 2, and we found out that 5 times 12 is 60, and 5 times minus R equals to minus 5R. So in conclusion, we found out that 60 minus 5R equals to 13R. We added 5R to this equation number 2, and we found out that 13R plus 5R is 18R. So 18R equals to 60. We divided this equation number 2 by 18, and we got that the radius of the semicircle equals to 60 over 18. We divided both the numerator and the denominator of this number by 6. 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units. And then the area of the semicircle will be equal to pi r squared over 2. R is 10 over 3, so r squared is 10 over 3 squared over 2. 10 over 3 squared is 100 over 9, all divided by 2. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, we actually found out that the area of this of the semicircle equals to 17.45 square units. Okay, so this was the first method. Okay, and then we actually found out the area of the semicircle according to the second method. In the second method, In the second method, we used the two tangents theorem, or rule number 2. According to rule number 2, according to rule number 2, use the two tangents theorem, and according to rule number 2, or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and we have the external point P of this circle, and from point P we draw two tangents to this circle. The first tangent is PA, the second tangent is PB. Then the length of those two tangents that exited from an external point to that circle will be equal to each other. That is to say, PA equals to PB. And we can actually implement rule number 3 in our drawing, because in our drawing we have the external point C, and from the external point C we have two tangents to this circle, tangent CB and tangent CD, and according to rule number 2, two tangent theorem, they are equal to each other. That is to say, CB equals to CD, but we know that CB equals to 5 units. It is given as the equation. So from this equation, we will get that CD also equals to 5 units. So we know that CD equals to 5 units. And so we know that CD equals to 5 units. And because of the fact that we know that CD equals to 5 units and AC equals to 13 units, then AC minus CD equals to DA. So DA will be equal to 13 minus 5, that is to say 13 minus 5 is 8, so DA equals to 8 units. And we know that OA equals to 12 minus R and DO equals to R. So we implemented the Pythagoras theorem in the right triangle, triangle ADO. According to the Pythagoras theorem, in the right triangle, triangle ADO, AO square equals to AD square plus DO square. AO equals to 12 minus R, so AO square will be equal to 12 minus R square. AD equals to 8, so AD square is 8 square, 8 square is 64, plus DO square. DO equals to R, so DO square will be equal to R square. Here we open the brackets of equation number 1, and we got that 12 minus R is 144, plus R square minus 24R, and it equals to 64 plus R square. Here we have R square on both sides of equation number 1, so R square will get cancelled, and we left only with 144 plus minus 24R equals to 64. We subtracted 64 from this equation, equation number 1, and we got that 144 minus 64 is 80. So in conclusion, we found out that 24R equals to 80. We divided this equation, equation number 1, by 24, and we got that the radius of the semicircle equals to 80 over 24. We divided both the numerator and the denominator of this number by 8. 80 over 8 is 10, and 24 over 8 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3 units. And then uh, the area of the semicircle equals to pi r squared over 2, r equals to 10 over 3. Therefore, the area of the semicircle will be equal to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So that was the second method. Then we found out the area of the semicircle according to a third method. According to a third method, we actually drew a mirror image of this figure. We drew a mirror image of this figure, and we joined the two figures together, and in this way we actually created a circle that is inscribed by a triangle, and I repeat again, we drew a mirror image of this figure and joined the two figures together, and in this way we created this circle that is inscribed by triangle ADC. We know that AD equals to 13 units and AC also equals to 13 units, BC equals to 5 units, and DB also equals to 5 units. So DC, that is the base of this isosceles triangle, equals to 10 units, and AB, that is the height to the base, equals to 12 units. So the area of triangle ABC equals to the base of times the height over 2. The base is DC, and the height is AB, all divided by 2. DC equals to 10 units, AB equals to 12 units, all divided by 2. So the area of triangle ABC equals to 10 times 12 over 2. 10 times 12 is 120, 120 over 2 is 60 square units. So we found out that the area of the isosceles triangle ADC equals to 60 square units. And we know that the radius of any circle that is inscribed by a triangle is equal to the area of the triangle that blocks the circle over the semi-perimeter of this triangle that blocks the circle. So we have triangle ADC blocks this circle, so the area of this triangle over the semi-perimeter of this triangle ADC will be equal to the radius of this circle that is inscribed by triangle ADC. And we already found out that the area of triangle ADC equals to 60 square units, and the semi-perimeter of the triangle ADC equals to the perimeter over 2. The semi-perimeter is AD plus AC plus DC over 2. AD equals to 13, AC equals to 13, and DC equals to 10. So 13 plus 13 plus 10 is 36 over 2. 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC is 18, and the area of triangle ADC is 60. So the area of triangle ADC over the semi-perimeter of triangle ADC equals to the radius of the circle that triangle ADC blocks, the radius of this circle that triangle ADC blocks, that is the radius of our semicircle. So 60 over 18 is 10 over 3, because we divided both the numerator and the denominator by 6. 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3, and the area of triangle, the area of the semicircle equals to pi r squared over 2. And The area of the semicircle equals to pi r squared over 2. R equals to 10 over 3 units. Therefore, pi r squared over 2 equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the third method. Then I presented to you how to find out the area of this semicircle according to the fourth method. According to the fourth method, we actually defined this angle as angle theta. Okay, this angle is defined as angle theta. And if we focus on the right triangle ABC, on the right triangle ABC, the area of the right triangle ABC, sinus theta equals to BC over AC. Again, in the right triangle ABC, sinus theta equals to CB over AC. CB equals to 5 units, AC equals to 13 units. So we found out that the area of triangle ABC, according to equation number 1, equals to 5 over 13. Then we focus on the green triangle ADO. Here, sinus theta equals to OD over AO. Sinus theta equals to OD over AO. OD equals to R. OA equals to 12 minus R. So in conclusion, we found out that the sinus theta according to equation number 2 equals to R over 12 minus R. And sinus theta according to equation number 1 equals to 5 over 13. But we know that sinus theta according to equation number 1 must be equal to sinus theta according to equation number 2. That is to say, we created equation number 3 that states that sinus theta according to equation number 1, that is 5 over 13, must be equal to sinus theta according to equation number 2, that is actually R over 12 minus R. Okay, this is equation number 3. Then we cross multiplied equation number 3 and we found out that 5 times 12 minus R equals to 13R. We open the brackets on this side of equation number 3 and we got that 5 times 12 is 16, 5 times minus R is minus 5R. It equals to 13R. We added 5R to this equation number 3, and we got that 60 equals to 30R. 13R plus 5R is 18R. So we found out that 60 equals to 18R. We divided this equation number 3 by 18, and we got that the area of the semicircle equals to 60 over 18 units. 60 over 18 is 10 over 3. So we found out that the area of the semicircle equals to 10 over 3. And the area, the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle is pi r squared over 2. So pi r squared over 2, and we know that r equals to 10 over 3. Therefore, we actually found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, thank you very much.